How to build a Blackgates Sweet Pea 5-inch gauge locomotive. Part 33. Cutting the blast pipe to the correct length, threading the other end 1/2 inch by 26 threads per inch, then making and fitting the blast nozzle. And why is this blast nozzle required? Just in case you're wondering why this opening title is blurred, it's because it is a copyright image. I have permission to use the book cover, but not permission to use any of the drawings from within the book, which is fair enough. Besides, it's a really good idea if you're building a Sweet Pea to buy this book. It's full of a wealth of information that is extremely useful, and it's far less cumbersome than the large drawings. The blast pipe needs to be 5 3/4 inch long from the centre of the horizontal piping. This dimension isn't critical, so I just held the ruler against it and made the first of 2 felt tip pen marks on the blast pipe. Why did I use 2? I suddenly decided to cut the blast pipe slightly longer because it's better to cut it longer than shorter. You can take the metal away, but putting it back is much more difficult. It's time to unscrew the blast pipe and fit it in the chuck of my Boxford lathe. But not before I show you the 2 felt tip pen marks for a second time. The next bit is simple. With the blast pipe in the chuck, I simply part it off with the very thin parting tool that I use. This allows me to part off far more quickly than using the larger parting tool. In this part of the clip, I'm applying some cutting lubricant because I'm going to thread the other end of this tube 1/2 inch by 26 threads per inch, just like the other end. This is a close-up shot of me doing the job manually, and I'm also showing how I keep pushing the tailstock chuck up against the die holder to check that it's running true. Just like this, in fact. You do not need to put much pressure on the die stock, that is, of course, unless it starts to wander about. Just gentle pressure with the tailstock chuck keeps it running true. Not exactly precision engineering, but then again I am not a precision engineer. But I play a mean Hammond organ, and have done so for many years. I pulled the work out of the chuck a little bit because I needed to thread it a bit longer, and I applied the lubricant from the back. A few more turns did the trick, and the thread at this end is now about the same as the one at the other end. That's the job done. I backed off the tailstock chuck and unwound the die from the work. I do like using these pre-loaded die stocks. It's far quicker than fitting dies into a tailstock die holder all the time. These are split dies and I can set them up for perfect accuracy. The threads need to match the nuts, not slack and not tight. A quick clean-up of the end of the thread using a file, and that's one more job done. A blast pipe is no good without a blast nozzle, and the scan from the book tells me to make it from brass. Here you can see the approximate shape of the blast nozzle, but I've blurred out a lot of the detail, for reasons that I've already mentioned. Back over now to the Boxford lathe, and in the chuck is a piece of brass hexagon. I centre drilled it, and here I'm drilling it tapping size for 1/2 inch by 26 threads per inch. Threading it under power with a manually operated tailstock chuck was never going to work. Instead, I used a large tap wrench and did it manually. I've engaged the back gear inside the headstock to prevent the chuck from rotating too much. You do need a good bit of strength in your hands for this job. I'm at a bit of a disadvantage at the moment with the medication I'm taking, but there's enough power there to thread this. In no time at all, the thread is long enough to screw onto the blast pipe. The next part of the job is to drill a 1/4 inch diameter hole in the middle as shown on the drawing. The overall length of the blast nozzle is 3/4 inch, and here I'm making a mark with the tip of the ruler, but I didn't think that was a good idea, so I used a felt tip pen. Then I simply separated the blast nozzle from the main bar stock using the parting tool. Once again, it's a very easy job, and in no time at all the part fell off into the chip tray. I cleaned out the chip tray so I didn't lose the part this time. Then the doorbell rang. Cue doorbell special effect. It was my son-in-law Rob. Rob is a farmer and he wanted me to modify a stub axle on a really old trailer This job took quite a while and I really don't know why I didn't buy some new roller bearings, but that's the way it is. I turned down the stub axle as shown here and the part only just fitted in the lathe. An hour and a half later I returned to making the blast nozzle. Here I'm shaping the end of the blast nozzle using 2 lathe tools just to make it an interesting shape. Nothing difficult here, just a bit of routine turning. And it's starting to look like a blast nozzle. The final part of the job is to make sure that the hole in the centre is 1/4 inch diameter all the way through. The hole was nearly all the way through, so I didn't need to use a centre drill. I just made the hole larger. Once I'd done that, I cleaned up the end using a piece of emery cloth just to get rid of the burrs. I removed the finished blast nozzle from the chuck and screwed it into position on top of the blast pipe. And because of the accurately set die in the die holder, the thread is absolutely perfect. No shake, rattle or roll on it at all. It's really important that this part doesn't come loose in service because it would fly up the chimney at an alarming rate. So, the question is, why do we need a blast nozzle? Steam engines are gas engines and it's advantageous to make sure that when the steam has done its work, it can go up the blast pipe with the minimum of resistance or back pressure. It's a trade-off really because the blast nozzle does put a little bit of back pressure into the system, but it increases the velocity of the steam going up the chimney, which in turn draws the fire. The fire burns brighter, more heat, more steam. It's a constant reaction. A 1/4 inch diameter is the recommended starting point, but I'll have to be prepared to enlarge the blast nozzle if the drafting is too severe and the grate burns out. I've burnt out a few in my time. Tomorrow I'm going to Blackgates Engineering to buy some piston rings, so I thought it would be a good idea to take the piston with me. I originally fitted silicone O-rings, but I think that proper, professionally made cast iron piston rings will be much better for the job. Whoever turned this cylinder cover made a mistake, and there are 3 plugs where the holes for the glands were drilled in the wrong place. And one of the plugs is a little bit too big, so here using a grinder, and by moving it from side to side whilst rotating the cylinder cover, the size of the gland becomes the size it should be. This clip shows what the problem is. You can clearly see that one of the plugs is encroaching on the diameter of the hole, but not anymore because I ground it away. I'm cleaning up the outside of this cylinder cover using a piece of emery cloth, but I can only go so far because it is badly marked in places. The man who built this at this stage didn't have a great deal of finesse, but that's the way it is. I can only improve it, not make it perfect. That's it for this episode. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.